Okay, today I just want to teach you how to find out the volume of symmetrical body when we have rotational symmetric around an axis like this. For an example, I will tell you what we're going to do. Let's have a look at this function. Actually, let's call this y equals to square root of x, right? Okay. Now what I'm going to do is I'm going to rotate this y equals to square root of x on the positive square root of x around x-axis 2 pi radians, right? By 2 pi radians around x-axis. So you can imagine what would be happen there. So the solid body can be formed by rotating it around its own axis by 2 pi radians, right? So 360 degrees, right? Okay. So you can see there is a cubic body. So if you want to find out the volume of this body, what we can do, I want to tell you some more things regarding this session. We can't do this always because you will not be given these type of symmetrical rotation symmetrical figures always, right? Only if there is this rotational symmetrical figure, if you want to find out the volume of that, then you can use this single integral, use this sneak way to find out the volume, or even you can find out the area. So in this video I hope to talk about the volume only, right? So fill the I'll, I'll capture this position, right? I'll capture this position. Please just pay attention on this. You can see there is a very tiny slide, very thin slide. It looks like a disc, pretty much a small disc, right? Okay. So the width of that disc, which is measured along x-axis, can be called something dx, right? Actually, this is the operator delta x. Delta x goes to 0. We can call it as dx, right? So then let me change this color. This is the radius of that disk, right? Okay. So how we can find out the pretty much small volume of that disk, dv? Actually delta v approaches 0. dv can be written as pi r squared times dx, because the width is going to be equal to dx, right? Actually you can see when little axis change, when this exercise change, this radius must be changed, right? According to the function, function may guide up the radius of this body, right? So how we can change this radius? Actually, radius is nothing as the ordinate, right? Radius is nothing as the ordinate. Y is going to be equal to square root of x. Y is going to be equal to square root of x. It is nothing as the radius. So we want to find out the square of radius, square of radius, right? Okay. Now I think you have the idea of this. We want to substitute here y square. Y is the square root of x, then y square is just x. Pi x dx is going to be equal to dv. We want to find out total volume, so it must be integrated. All these slides must be integrated. All these slides must be added together. Actually these are molecular parts. Even we can't call them as molecular parts. Even they are pretty much smaller than molecules, right? It tends up to 0. It's just like something which was discussed in Abhidharma. It's unique for each of your records, just like if I explain it furthermore, when delta t approaches 0, it is known as Titakshana, right? Actually, I also do not feel that that type of a particular moment which cannot be accessible. I think how we are not we are poor, and we are not rich enough to access that moment. That much of very much small time duration is known as diffraction. And also when we break these matters into pretty much small parts in ancient days, they call them those atoms. This is formed with atoms. Atoms cannot be divided furthermore. No, no, no. We know nowadays even we could differ them. Even we could split them into pretty much small parts called known as electrons, protons, neutrons, positrons, etc. Right? Even in this century, um, there was another invention. Even these scientists could invent that even these electrons can be divided. But the amazing thing, really, I'm really astonished. Actually, we have never seen this, and it doesn't make sense. But with experiments, we could say this is made of these, this is made of these, and if they are not true, the depending moments will not be worked, but they are working. It means actually they happens like that. But I think it is incompleted. We have to go furthermore. Uh, that is what is called as um, apotheosis pottery, like that, right? Actually, I also can't explain it furthermore because it doesn't make sense to me also, right? But I think that's the most primitive moment we can go. We can't go furthermore rather than those elements. Everything is made of that, right? So like that, then we can. This is the moment it was ended up, right? But it doesn't make sense, right? So because delta x approaches to 0, you can't say that is 0.0000001. You can put 0 point a million much of zeros then after 1, right? Even you can't wait after that. Even you can't go furthermore 0. 10 billions, 10 billions much of zeros, put 10 billion much of zeros then after that 1, right? So that's really it tends up to 0, but there is a digit we can never access, we can never catch. There is a digit, it is unique for each of the thing, right? So like that we can integrate these, we have to integrate. I have not defined the height of this, let's say this is a bullet, right? This is h, so you want to integrate it from 0 to h, right? So then you can find out the volume of this body. So that's how you could find out the volume of this body. So in my next video I hope to present to you the surface area of this type of symmetrical body, right? After that, let's talk about how to handle undulated bodies with helping of double integrals and triple integrals. This was done with helping of a single integral by rotating around its own axis, so you can handle it. So I would like to invite you to find out the when it is rotated around y-axis. I have rotated it around x-axis, but you can find out the volume where the body when the function is rotated around y-axis, right? Okay, so thank you. I am Sapumal Senadi Sasanka Sagar.